All right.
Sir?
So, like I said, there are various methods that are being employed for load estimation, and referring to the fact that there are manual methods of doing so, and also computer-based methods. All right. So, but for this particular lecture, I'll be showing to you how load estimation is done for basic structural elements. All right. So
Yes, sir.
there are three basic forms of loading condition constituted by vertical loadings. And I would like to say there are
Yes, sir.
three
Three
basic
basic
forms of loading condition.
forms of loading conditions
Yeah.
that are
Yes. That are constituted by vertical loading. You know, I spoke to you about gravity loadings yesterday, or gravity loading.
yes, sir.
Yeah.
Yes, sir.
So you may take reference from yesterday's lecture.
Yes, sir.
All right, so the number one, the very first type or form of loading is the uniformly distributed loads. Uniformly distributed line loads. I know that
Line.
line load. I know you must have heard about UDL. All right,
Yes, sir.
that's uniformly distributed load, and that's exactly what you see that is usually represented when we have a free body diagram such as this. So when you see a drawing, a free body diagram like this, and you have something like this. This one shows the UDL in the middle, right? And sometimes you may choose to represent it like this. Either of the two. You see that now. So that's UDL. So the second one we have is the triangular or trapezoidal load. Triangular or trapezoidal load. Okay, now looking at this, if you have a slab, a panel of slab or a slab panel like this, for an example, if this is LX and this is LY,
Yes, sir.
now when this slab panel is loaded, we have something we call yield line. Yield line analysis basically is such that the portion of your slab is um, actually it's proportion by the effect or the influence of that load. And it is actually represented by the shape on the slab. So this is what I'm saying. So
Sorry, sir. Can you the portion of your slab be proportional to the
is what?
you said you're explaining it, the portion of your slab is
Yeah,
proportional to the
I said the yield line actually it tells of the proportion or the amount of loads that is transferred or transmitted to any portion of the slab or any size of the slab. So this is what I'm saying, in case you don't know. I'm speaking to you this way because it's a basic class. So I'm trying to make all my explanation um, very simple for you to understand. Now, if you look at what I just drew now, The reason why I agree with this way, you discover that the shorter side, which is the LX, carries the
Yes,
triangular
sir.
load. This is the triangular load,
Okay, sir.
that shaded portion. That's the triangular load. Now, the amount of load that is coming on this side of the slab, and this side of the slab will be equal to the area of the load on the area of this triangle. Did you get that?
Sorry, sir. I didn't get that.
I said the amount of load that will be coming to this side of the slab and this side of this
Yes,
slab
sir.
will be proportional to the
Yes, sir.
area of this slab, of this triangle rather,
Okay, sir.
area of this triangle. So in like manner, the amount of load that will be transmitted or transferred to this side of the slab panel and this side of the slab panel will be proportional to the area of this trapezoidal shape. Will be proportional to this area and then proportional to this area. I hope you are getting me. All right. So that's what we mean by triangular and trapezoidal loads. So I was saying that what a triangular or trapezoidal load, how we actually arrive at that kind of load is such that we draw a yield line, and I already told you what yield lines are. The initial shapes
Yes, sir.
that I drew out on this slab panel, for example, are the yield lines. And now when you finish drawing out your yield lines, you discover that you have two basic shapes. You have the triangle, and then you have the trapezoidal shape.
Yes,
Now, so
yes,
I
sir.
said that the amount of load that will be going to this side of the slab and this side of the slab will be equal to the
It's
area
proportional.
of that triangle at that point. All right.
Yes.
And then the one supported by this side and then
The
this side.
LY side.
Yeah. So would
Yes, sir.
be um how much, and that's what I mean by the proportion. All right. Will be equal to the area of the trapezoidal shape that is there. I hope you get that clear.
Yes, sir.
Okay,
One and
good.
two is proportional to the area of the triangle,
Yeah,
and three and four is proportional to the area of the trapezium.
yeah, yeah. So
Yes, sir.
we have the third one, which is the concentrated point load. So you may have a beam, for example, if this is the Peabody diagram, and then you have a concentrated point load right at the middle, like this. So this is a concentrated point load. Yeah.
Yes, sir.
So, and having understood these three basic forms of loading condition, another thing that will be very important for us to know is I told you yesterday rather, about the
Yes, sir.
loading sequence, that is load transfer sequence, how load is being transferred in a structure.
Yes, sir.
So I'll make a simple illustration. Let's assume that we have a one-story building.
Yes, sir.
This is a column, for example, another column, and then another column. These are the three columns. Then we have a beam at the roof. So you may call this the roof. We have another beam. You may call this the first floor. Then we have a ground floor. This is a ground floor. Ground floor. Okay, so let's assume this is the foundation now,
Yes, sir.
the pad foundation. So what we want to do is to understand the load transfer sequence, how load is being transferred throughout the structure till it gets to the bearing strata. So let's just do a loading. Let's load it somehow. All right. So
Hello? Okay.
so now looking at this, what is this loading condition called? What is this form of loading called, rather?
UDO.
What did you call it?
UDO. The one,
Mm.
that number one.
So this is UDL. What of this? What is this called?
It's also UDO, sir.
Also UDL. All right. So now listen to it. We have two stories basically. Story
Yes,
one
sir.
and story two. So we want to call it that. Now,
Yes, sir.
so if this let's assume that this is story one, of which some people don't call it that way. Some just call it ground floor. All right. Or you may call it story 00. Well, however it is you want to call it, but just know that is the ground floor. All right, and then call it story two. Let's just call it story one and story two, so that it gives us less less stress as we go. Story one and story two. Okay, so how does this load transfer sequence? How does it operate? All right, trying to put this inside my. Okay, so looking at this from the story two, this is the roof beam. This is the first floor beam. So for story two, for example, what we have is this. The roof, if it's a normal roof, it can also be a roof slab in case of a
Yes, sir.
concrete roof. The load there will be transferred straight to the roof beams. Are you there with me?
Yes, sir.
So these roof beams sustain the load from the roof or the roof slab. Then from here, it moves down to the column at that floor. That is to say that the load from the roof or whatever it is from the roof gets to the roof beams, and these roof beams transfer the load into the columns.
Yes, sir.
So these are the column, column. That's on this floor. All right. So on the story one, which is the one below, the same arrangement happens, except for the fact that this case, it is the floor slab that the load is transmitted to the first floor beam, the beam, and then the beams does the same to by sending to the column. Other, all right. So the load comes in,
Yes.
it comes in, and it comes in. Then remember that this column and this column gets connected at this point. Do you notice that?
Yes, sir.
So it means that after each stories transmits their load, they are all coming into the column at this level. Do you get what I'm saying?
Yes.
Good. So the column takes it now to the foundation at this place. So this is how the load is being transferred from the top to the bearing strata, which is called the foundation. So let me talk about the design load so that we'll find a good place to wrap up for tonight. And I'll give you one or two things to do. Then we'll meet for proper calculate. We'll start the calculations in the next class. All right. So let's talk about the design load quickly. Design load. You see, these things are fundamental if you want to um, allow us to run at a very reasonable pace when we start the calculations. It will help you.
Yes, sir.
Yes, it will help. So, design loads. To obtain the design load, we usually apply the factor of safety, all right, for loads. I will multiply it by the values of the dead load, and we also multiply it by the value of the live load. So, in expression, this is what I mean. The design load denoted as N is equals to 1.4, which is the factor of safety, multiplied by the dead load plus 1.6, multiplied by the live load. All right. So where did we get these things? The value of this dead load, I already told you yesterday, is from the load of the permanent element or the structure itself. Okay. I mean dead load, I mean dead load, not live load.
Yes, sir.
Not live load. Let me rub off that one so that it won't confuse you. I mean to say dead load, not live. Live load is the weight of the temporary structures.
Temporary, like me. People
Temporarily,
that will be moving.
exactly. So,
Yes, sir.
so this one can be obtained by calculating the load of the structures and the element itself and all of those things. But the live load it varies depending on the usage. I hope you got that.
Yes, sir. Live load depends on the building.
It varies depending on the usage of the structure, on the usage of the structure. Okay. So, and you can always obtain this from the BS 6399, Part 1, 1984. All right. So, we have different kinds of life load in that particular code of practice. Remind me probably during maybe tomorrow to share with you this particular code of practice so that you can lay your hands on it. So it's actually on table 8, if I'm correct. Table 8 of that particular code of practice. You find residential occupancy class. Table 8. Right. Can you still see my screen? All right. So, um, I believe you've been able to get one or two things from our communication tonight, and I wouldn't know if you
Yes,
have
sir.
any questions at all.
No, sir.
You do not have questions.
No, I do not.
Okay, so
And
I'm happy you don't. It means the
so,
explanation is so clear.
so
Now, if
yes,
we move forward from here, it means that we have to go ahead into many more things. But I would like us to do that in the next class because it involves calculations, and I would like to
okay,
apply.
sir.
We'll be applying these things we just learned at as simple as it is. We'll be applying it in the estimation of loads. So in our next class, which is supposed to be Thursday, your music is on time.
Thursday, right?
Yes, Thursday. You prefer this time? So,
Yes, sir. Will
oh,
you be free like during the day?
during the day Thursday, I should be, but I would let you know. I'll let you know. So, so that we can take our time to apply all of these things that we went through. So,
Yes, sir.
yeah. So, pending the time, I would like you to do something for me.
Yes, sir.
I'd like to do something for me. Yeah. I'd like you to go and check out, study on load estimation. Everything you can lay your hands on as touching load estimation, particularly on slabs, beams, basically these two before next
Yes,
class.
sir.
So by next class, I will
No,
teach properly to see, the advantage you have if you do it properly is that it will make it more easier for you to understand what I'm doing.
yes, sir.
So that'll be all for tonight. See you on Thursday by 10 p.m. Yes.
Okay, sir.
So have a very good night.
Good night, sir.
Yeah, bye.